Bismillahirrahmanirrahim. This may be the last lecture, although there is a lot of work that remains. In fact, today I will cover a lot of ideas, but I will not cover the techniques and the specific programming and models that you will be asked to do. This I'm basically going to cover chapter 10, which you have seen, which has been distributed, photocopied. This basically covers the theory of how we estimate a consumption function, and then there is an appendix which has step-by-step details on how you do it. So this is going to be your project for this course. You have to take some consumption and GNP data for some country, and everyone must choose a different country. So the way to do that is to choose a country and just have Amna write down your name with the country name. So whoever gets to her first, that's the country. But make sure that not all the countries have all the data. Most of the countries have, but it should have data up from 1960 about to 2010, which is about 50 years. A little bit less or more doesn't matter, but it shouldn't be too short. So as long as you have about 50 years of data, that should be okay. Now the methodology then you will learn how to do is the latest methodology on how to estimate. So you will hopefully understand that running a regression is not just taking two variables and putting it into the computer. A lot more work is involved. Okay, so that's the background now. So we are just going to go through some of the issues, and as I said, I'm going to cover mostly the words and meaning part, which means that you will have to work on the technical details. I'm not going to describe the technical details here. So you will have to work it out. This is actually necessary if you're going to do a master thesis. Then basically this is how it works. I give you the ideas, and then you have to work fairly hard to understand what the work is. You can't really understand math by having somebody explain it to you. You have to do it yourself to understand it. I think in the last lecture there was it was covered, and you have Amna can give you an additional lecture if you need on how to do the consumption function estimation. Okay, so basically the consumption function is a very important function in the sense that, according to Keynes, basically what happened in the Great Depression was that there was a shortfall in aggregate demand. Now, actually you might want to watch my lecture on macro to understand the relevance of this theory. So now the question becomes, how is aggregate demand determined? If you have enough aggregate demand, then you will have, your economy will not fall into recession. So he invented this idea of the consumption function. Basically, aggregate demand is determined by your income. So this leads to basically the main issue is, you see, the Great Depression poses a problem for economics in the sense that you have an economy which was booming. The period was called the Roaring Twenties. Everything was going. There were lots of factories and lots of shops, and everyone was having great business, and people were making money, and things were getting produced. And for about 10 years there was prosperity. And then suddenly everything collapsed, and millions of people are out of jobs, the factories are looking for workers, and the laborers are looking for jobs. How come? How can the economy work for 10 years and suddenly how can it collapse? When there was no war, there was no earthquake, nothing, all of the factories are sitting there, the workers are sitting there. So basically what Keynes said is that there was a problem due to a collapse of aggregate demand. People were not demanding things. If people were going to demand things, then the factories would produce. And when the factories produced, then they would have to hire people to give them jobs. And when they got the jobs, then they would have the money. So there was sort of a communication problem in the economy, a signaling problem. He said that there was demand, but it was not effective. It was buried. If the factories were producing, then the demand would be there. But the factory didn't produce because they didn't see any demand, and the laborers didn't demand because they didn't see any jobs. But if you just started the process off, then everything would be fine. And that was what he meant by monetary policy and fiscal policy. He said that you just ask some people to dig holes and then you pay them, and then you ask more people to fill in those holes and you pay them, and they will get the money from this fake job, and then once you have the money, then they will start spending and the demand will become effective and the factory will start going, and once they start, then there will be a cycle in which everybody will get a job. So the consumption function, how is this aggregate demand determined? This is one of the key pieces of the Keynesian theory. And Keynes came up with what is now called the AIH, in this chapter, the absolute income hypothesis, that basically aggregate demand is determined by your current income. So if the economy is such that there is a huge unemployment, then the aggregate demand is going to be very low. So the point is to increase the income somehow artificially. That will make the demand high. Now the question of how to determine this aggregate demand is very important. Is this really true? So people were looking at the data, and the initial and to find out if there is a consumption function and can it be estimated. So they had data on consumption and on income, but there were some issues that if you have a consumption of something like food, then of course that's a non-durable item. But if you buy a house, that is consumption, but it's not really consumption in that period. It's a durable good. So the thing that you're buying is consumption over several years. So then the problem is, how should you calculate that consumption? Suppose that you're going to live in the house for 30 years. So if you spent $1 million on the house, then should you divide it into 30 and count your consumption as being 1/30th, or how you do it? So there were many problems like that. Then there's the question of income. What is income? Income is it the money that you are being paid as salary, or should you take out the tax, which is actually disposable income? So disposable income is equal to gross income minus taxes plus transfers. Sometimes you get money from the government in the form of various subsidies, or money is taken away. So if you take out the taxes and put in the transfers, then you get with disposable income. Disposable income is the income that you have at your disposal to spend. So instead of gross income. So these were some of the ideas that you have to decide which kind of income to use, which kind of consumption to use. These were being decided. Then the problem is that you have aggregate data. So now, if different people have different consumption functions, then will there be a consumption function in the economy as a whole? You can say for each individual you have consumption as a function of the income, but when you add them all up, what will happen? It turns out that if you do things correctly and if certain assumptions are satisfied, then on the aggregate you would get a random coefficient model which means that C is equal to alpha plus beta y, but beta, instead of being a fixed number, should be a random coefficient. But this complication was ignored for the most part. Then the issue is what consumption function. I mean, you can take the aggregate consumption as a function of the aggregate income, or you can now there are several choices. Either you can take it in nominal terms without taking into account inflation, or you can take it in real terms, and again you can take it in gross, or you can take it in per capita terms. So basically it was decided that we should try to look at real consumption as a function of real income rather than nominal versus nominal, and also we should try to look at it in per capita terms rather than gross terms. There are some reasons for these choices, but it turns out not to make all that much difference. But then there was a serious issue of simultaneity. Basically, the regression model says that consumption is a function of income. So the causal chain runs from income to consumption. That is very important. This is called exogeneity, and there are some very difficult technical problems associated with the estimation if there is simultaneity. So if the consumption level actually determines GNP, or if both are determined by a common cause, this is called a simultaneity bias. So the equation, the consumption function, is estimated under the assumption that y is exogenous, which means that y is determined by some factors which are outside the system. This is a very vague and not very satisfactory term. And then income determines consumption. The only key thing is that consumption should not then go back and determine income. If that happens, then you have a problem. As long as consumption, once you fix income, that determines consumption, and there are no feedback effects. If consumption itself goes back and the level of consumption then determines income, then you have a problem of simultaneity. In the case of the simultaneity problem, the OLS estimation method doesn't work very well, although the consumption function may well be there, but obviously there is some other relationship which is also there, which is being missed, and that needs to be taken into account to do the estimation correctly. So again, this has been more or less ignored. Some people have tested for simultaneity bias, and under various kinds of assumptions they have found that it would not be serious. But all of these issues came up. The most serious issue, the one which makes a big difference, is that you have non-stationary regressors. Both consumption has an increasing trend and the GNP has an increasing trend. This is a very serious issue because if you take the consumption of any country and run it on the GNP of any other country, you get a very good equation. So this means that just because you have high R squared and significant statistics, that doesn't mean that this is a valid equation, because it could be what is called a spurious regression. It could be that the relationship looks good only because both of the series have increasing trends, and actually there is no relationship. So how do you solve this problem? This became a key question in economics since basically the 1980s, when it was first put. There is a paper which is Nelson and Plosser wrote a paper on the integrated series, and basically they showed this phenomena of spurious regression, after which it became a great concern and thousands of papers have been written on it. And the modern methodology is very much based on the need to avoid this spurious regression. So there were several things that you could do to avoid this stationarity, avoid this non-stationarity, and basically it involves taking the trend out of the regressors. Now that led to a different problem. There are two types of trends. One trend is called the deterministic trend, in which basically if something is a function of time equals alpha plus beta t, then that's a deterministic trend. And to remove that trend, basically what you need to do is to run a regression of that variable on time and take the residuals from there. And that will get rid of the trend. But the other kind is called a stochastic trend. A stochastic trend is when the level of the variable depends on what happened to that variable in the last period. So there is a trend, but it is a random trend, because what happened last period is random, and then every period you have a change. So a stochastic trend is also called a unit root process for reasons which I won't have time to explain in this lecture. I think I have, if you look at one of my applied econometrics lectures, there is some explanation of all of this in more detail. In fact, I didn't check it, but I think that these lectures are present in more detail than I have done in this course, in the previous course. So I will look for it and maybe I can post a link of it. So there are two types of trends. There's the stochastic trend and the deterministic trend, and unfortunately it's a serious problem that if the data follows a stochastic trend and you detrend it by using a deterministic trend method, that causes further problems. And if it has a stochastic trend, if it has a deterministic trend, and basically the way to take out the trend for a stochastic trend is to take the first differences. If you just subtract Ct from Ct minus 1, this is called the first difference operator, that gets rid of the unit root. So there are two different ways to detrend series. One is for the stochastic, and if you make a mistake, then it causes serious problems. And in addition, so the thing to do would be to try to find out whether this series has a stochastic trend or whether it has a. So this is what unit root testing is about, finding out whether a trend is stochastic or not. But basically, one thing that was discovered was that these tests are not very good, in the sense that they don't have a lot of power to discriminate between one case or the other. They can frequently make mistakes. So this is the current state of art. There is no very good solution to it, and basically some people are saying we shouldn't do this at all and we should find a different way to think about the problem. And that's where that's my position also, that this unit root integration stuff, which is the current methodology, is wrong. It doesn't do what it's supposed to do. One of my students has written a thesis on how you can use these tests to get whatever result you want if you do things correctly. So these tests are not very good and not very useful, and that's why I wasn't planning to teach this, but you need to know this in order to understand what is being written, also to write a currently acceptable econometric paper. So we are covering this just so you know what is going on in econometrics. So this non-stationary regressor is a very big problem, and in fact nearly all of this chapter, the methodology that you will be studying in the appendix, is basically built on this idea that how can we take care of this problem. that takes most of the work that is being done here. So basically the solution when you have stationary, so as I said, the first idea was to take the trend out. That doesn't seem to work very well. People tried that for a while. And so then the next idea was the co-integration. Basically, if the two series are integrated, then there is a possibility of a spurious regression, or a regression which looks correct but is wrong. And the way to fix that is to check for co-integration. If the two series which are integrated are also co-integrated, then you can guarantee that the regression is genuine and the results that you're seeing are not wrong. So that's the basic summary of the idea of co-integration. Now, the final finding in the early stages was that the short-run marginal propensity to consume is less than the long-run marginal propensity to consume. This was not in accordance with the Keynesian absolute income hypothesis. In this situation, if the current income determines the current consumption, this is what is called a static relationship. So in every period there is some consumption, some income, and some savings, and every period is different and separate, and there is no relationship between what happens in one period and what happens in the next period. This is what this turns out not to be true. Basically, the data showed that this was not true. I wonder. Yes. Oh, this is pictures. Oh my God. How do we? Yeah, now we are in the right range. Yeah, this is the picture that I wanted to show you. So short-run consumption functions look flat. The long-run function looks like a straight line through the origin. This is what it means to say that short-run marginal propensity to consume is low, long-run marginal propensity to consume is high, when the slope is the marginal propensity to consume. So the slope is shallow, and furthermore the intercept keeps rising. The short-run function keeps going up as you move across time. Basically, the short-run function can be estimated by over short periods and with cross sections of data, because that's at a fixed period of time, and the long-run function is based on time series. And so basically there seemed to be a conflict Both this, basically the reason for this means that there is some dynamic in the consumption function, that the periods are related to each other. They are not separate. So now, once this empirical phenomena was observed, people started to think of how it could be and why it could be, and many different theories were invented to explain this phenomena. So many theories. There was the relative income hypothesis, which says that people look at relative income instead of absolute income. And then there was the habit persistence. If you have a certain amount of, once you get accustomed to a certain level of consumption, then you try to achieve that even if your income is not sufficient. There was the life cycle hypothesis, which became very important later on, which says that your income is low in the beginning and then it rises and then it becomes low. So your income stream has a U shape, while your consumption stream you want to maintain more or less constant. There's the permanent income hypothesis by Friedman. For our purposes as econometricians, it doesn't matter very much which of these is true. One only looks at the equation that you get. This is the attitude in, at least in Henry methodology, that it doesn't matter which theory is correct. The only thing which matters is what equation you get. But actually, this is part of the empiricist idea that the only thing which matters is the data. In reality, the mechanism is very important, and we need to know what is the real thing in order to be able to find out which equation is correct. So now I want to show you something about okay, look at this equation 10.4. This is the Brown's habit persistent. So consumption is proportion of income and then some percentage of last period's consumption. So the last period consumption represents the habit. Now if you look at this, you can immediately see that in the long run, if you have a stable income, then your marginal propensity to consume will be beta 0, but if you look at the short run, you will have a flatter income. You see the intercept of this relationship is beta 1 Ct minus 1, which will keep rising, because as time goes on, consumption will keep increasing. So if you don't have this variable, you're just estimating alpha plus beta y, then you will have a rising intercept, and also you can see that actually the slope will appear smaller if you misspecify the Ct minus 1. So basically this equation can be used to justify the idea that SRMPC is less than LRMPC. And just like this is the simplest one, that's why I showed it to you. All of the other, the permanent income and the life cycle hypothesis all of these can be used to justify the idea that short run is less than the long run MPC. And also they come up with fairly similar equations. Basically the point is that there is missing dynamics. What is dynamics? Dynamics is effects from the previous period. So basically all of the theory says that Ct minus 1 and Yt minus 1 are missing variables from this equation. That's now different theories have different variables. Like in fact, in the one of the what we were studying in Henry was that in one of the theories you have Yt and Yt minus 1. In another one you have Ct minus 1. In the so-called autocorrelation theory you have a function of Yt minus 1 and Ct minus 1. The error correction model puts in last period's error, which is Ct minus alpha Yt minus 1 as the missing variable. So anyway, all of these theories, in fact this is one of the Henry's one of his articles about how basically you can put in Ct minus 1 and Yt minus 1. That is what he calls the general ARDL model, autoregressive distributed lag. So autoregressive means that Ct minus 1 is there. That means that Ct is being regressed on itself. And DL means that Yt minus 1 is there. So lags of the Y are there. And of course, minus 1 and minus 1 are not necessary. You can also have minus 2 of both of those and minus 3 of both of those. If you have quarterly data, people generally go up to about 4 or 5 lags. If you have annual data, 1 lag is usually enough. This is a matter of experience that it's not a, in consumption functions about 1 lag annual is enough. In quarterly data, about 5 lags is enough usually. So the ARDL model is general. If you by making assumptions about Ct minus 1 or Yt minus 1, that one of them is there, the other one is not there, or some combination is there, you can get different models. And in fact he lists about 7 different models which people have put and argued about that this one is the right model. So he says that basically all of these models are special cases of the ARDL model. So you should start with the ARDL model, including the co-integration model. That's also a special case of the ARDL model. So the ARDL model is the most general model, and you can always get an ARDL model for the consumption function. You may not be able to get a co-integration model. You may not be able to get an error correction model, but the data might not support that, but the data will always allow you to fit an ARDL model. So different theories lead to slightly different equations. Now what is important is that, you see, Henry himself, the Henry methodology, takes an agnostic attitude. He says it doesn't matter which theory is correct, as long as my equation fits, I'm fine. This is wrong, as we will see, this attitude. In fact, you have to know which theory fits, but the problem is that this decision cannot be made by the data. The data does not provide enough information to allow you to tell whether it's habit persistence or whether it's life cycle or whether it's permanent income. So you have to do other things in order to find out. You actually have to go and investigate how consumers behave. So you have to find out about some real world factors which are not captured by the data. So basically the empiricist methodology, which is currently the dominant one in econometrics, I have a lecture which is called something like Logical Positivist Methodology in Econometrics and its Harmful Consequences. I don't remember. Actually, it's on available in my. It was a lecture that I delivered at PIDE. It's available from my web page. So it talks about this methodological problem that economists, the econometricians have adopted this empiricist methodology. Empiricist methodology is exactly this, that you look at how well the equation fits and then you don't worry about the real world aspect of it. And that's what Friedman does. Sorry, not Friedman, that's what Henry does. And that doesn't work because depending on which of the mechanisms is true, different equations will perform differently. And we will see that later on when we study what happened in the estimation of the consumption function. So basically the point is that all of these theories lead to somewhat similar equations, and basically the equation that you get is an ARDL equation with lagged values of consumption and income. Different theories put different kinds of restrictions on the coefficients. And the results don't favor any particular theory over others. You can support all the theories by the data. And so basically from this, Henry concludes that it doesn't matter which theory is right, but actually that's not the correct conclusion. It means that you have to use other sorts of evidence to find out which theory fits, because it does make a big difference, but your data cannot tell you. Now, in addition to these theories, there are some more variables which are missing. According to these theories, the missing variables are just the lagged values of y and c, but there are some additional variables, and one of these is price. So the price variable, if you have a real consumption function, so you estimate real consumption as a function of real income, then that means that there is no price illusion, no money illusion. So if there is inflation, people automatically adjust both their income and their consumption. But so now economists thought that there was no money illusion, so there should not be no effect of prices. So, but actually when you test, some tests reject price effect and find that there is no money illusion. Other tests find that there is money illusion. Now there is, this is what this shows, but actually there is very strong evidence now that price does have an effect, and it's not necessarily through money illusion. One of the things that happens is that if you have inflation, then some of the assets which are nominal, for example, if you have a pension that is guaranteed to you in numbers, that you're going to get so many pounds per year, then the value of that asset becomes less. On the other hand, most people argued that now everything has been indexed. So if the prices go up, then your pension also goes up. And if you have a real asset like a house or something, then because it's a real asset, if the price goes up, the value also goes up. So again, so they have argued that inflation makes no difference as long as you have a real. So you don't need to put in price as a separate variable in the consumption equation. And inflation doesn't matter. In the DHSY model, it did make a difference, but there are some special reasons for that we will see. Now there's another variable which is wealth, and that turns out to be a very important variable in determining consumption. So there is income, which is current income, but you find that wealth is very important. Even if you look at the highest data for Pakistan, you find a lot of people who have zero income, but they have significant amount of consumption. So you wonder where that is coming from. So basically it must be from assets that they own, which is wealth, which is not reflected in income. So wealth effects are important. So this is an important variable which is missing from the consumption equation. Now, we come to the DHSY model. The DHSY model is the error correction model. Remember that how it works is that you have delta C is a function of delta Y. This is the standard that was done to eliminate the non-stationarity. You take the difference of consumption. So if consumption is a unit root process, then that becomes stationary. You take the difference of income, and if that's a unit root process, that also becomes stationary. And then you regress one on the other. This is the first thing that was done in response to the idea that you have spurious regressions. So if you get a significance here, then that's serious because there is no longer non-stationarity problem. You should be able to see, it's interesting. So you will, if you take consumption in Argentina and run it on income in France, you will get a significant regression. But if you take the first difference of the consumption in Argentina and run it on the first difference of GNP in France, then typically you will not get a significant regression. So that shows that this can solve the problem of spurious regression. But this methodology has its own problems, which are in fact listed in DHSY article. One of them is that it gets rid of, this relates the short-run changes in consumption to short-run changes in income, but there is no long-run equilibrium in this model. If you run delta C equals alpha plus beta delta Y, then you don't get a long-run equilibrium. And basically, Henry says that the economic theory tells us about long run, so if you get rid of long run, then you are really getting rid of economic theory. Also, there are certain other problems which are listed by Henry about what happens when you just detrend. So to solve those problems, he introduces what he calls the error correction term. Later on, he said that error correction is not the right word, and he changed it to equilibrium correction, but nobody followed him. So even though equilibrium correction is a better name for the concept, it continues to be, actually it should be called the equilibrium correction model, but nobody uses this name. So the first name that he came up with is the one that has stuck. So basically he says that add another term, which is C minus alpha plus beta Y, which is the disequilibrium in the last period. Suppose that there is a long-run relationship between consumption and income, and the long-run relationship is C equals alpha plus beta Y. This is a long-run relationship, so it doesn't have to hold in every period. So in the last period, you look at how much difference there was. So if this difference is low, which means that consumption was below, there is an equilibrium. You have to think of it as CT, which is the actual consumption, and C star T, which is the equilibrium or the desired level of consumption, which would be alpha plus beta Y. So you look at the difference between the equilibrium level and the actual level, and now if the consumption is below equilibrium, then it should move up to, and if it's above, then it should move down. And I think that आपने last year ये cover किया था ना, the speed is also determined by the coefficient of the equilibrium correction. So if it's a small coefficient, then the move towards equilibrium is slow. If the coefficient is large, then you move rapidly towards equilibrium. So basically that's the second term. and that's the error correction model, and that model fit quite well, and it also encompassed the Wall and the W, D and B models. And in this model, the this model matched the B model well and did not match the other models, the H model and the W model, B model. And so basically this satisfied the error correction model of DHSY was encompassing the three models that he had studied. What does encompass mean? First of all, it should fit better than the three of them. Second of all, it should explain the three of them. This is the key concept of encompassing, that the truth can explain all existing models. And you say that if this is the true model, what would happen if I tested H, B and W? And you would see that one of them is a good fit to this model while the other two are not. And if that's so, then the one which is a good fit should appear to be the best among those three, and that's what happened. So basically he says that I have a model which explains all the findings in this field and is also better than all the others. But then what happened was that when he did a forecast with this model on the it failed miserably. The error correction model failed miserably. So he was unable to publish the paper because the last thing that he wanted to do was to show that the model fits well and also forecast well. But it fit well, but it didn't forecast well. So finally what he did was that he added a term which was basically an inflation term, so a delta P. This is completely ad hoc. Why should delta P matter? There is an issue. So, but it turned out that that fixed the problem. The forecasting became all right, and so then he published the DHSY paper with this one term added to the error correction model, which was the delta P term. Now this thing is exactly opposite of Henry methodology. I mean, Henry methodology says that start with a general model and reduce, not you start with some model and you find some flaw in it and then add a variable. This is exactly what he is saying should not be done, which is what he did in DHSY. So the thing is that this is basically what he is saying in the Henry methodology is almost impossible to do, because basically what he is saying is that you should field something which anticipates everything. But the point is that the data always give you surprises if you do a good study. If you study it carefully, you find that there are things there which you didn't expect to see. And so if you find something which is you don't expect, then you cannot have modeled it in advance. So the general model is supposed to be such that the data cannot give you any surprises. Everything that can happen is one of the special cases of your general model. But this cannot be done in practice usually. So one of the problems is that in DHSY model is that it just adds an ad hoc term for inflation, but there is no theoretical explanation for why this term should be there. And again, that's against the Henry methodology, because Henry says that your model should have a theoretical basis, but this model has no theoretical basis. So there are many interpretations which are possible which explain why DHSY fit well. Just like in the original, the Ball model fits well because of the fact that it accidentally approximates a good model, not because the model itself is good. So the Henry model also, the DHSY model also accidentally approximates a good model. So the second paper, which was basically written after the DHSY model failed, the DHSY forecast for 70 to 75, but some 5 years more of data showed that even that correction, the ad hoc inflation correction, did not work. So ultimately, again, the HUS model was written to fix that problem, and basically they said that, we went wrong in the DHSY model because we added this term on ad hoc, so now let's think carefully about how prices make a difference. So then he came up with adjustment to the income, in which he said, let's look at what happens as a result of inflation, and he took into account what changes in the real estate as inflation happens and what happens to stocks, and made some sort of a correction to the income term, and took into account the changes in wealth, and then he made a better model which works. But HUS model again failed after a little while. So then there was a third model which was created, and this process has continued. So we will discuss that a little bit later. What we want to do next is to discuss another very important strand in this literature, which came up with the Lucas critique. Basically, this was all happening in the 70s. In the 70s, there was a major failure of macroeconometric models. The 60s was a great time for econometrics. The econometricians were in control because the models worked very well and the forecasts were working very well, and so people thought that now we have the economy down to a precise science, and by making some small adjustments we can figure out exactly what's going to happen, and then we can fine-tune the economy to get exactly the results that we want. But then in 70s everything fell apart, and then people were bewildered, and as I said, there was the Lucas critique and the Sims critique, which were opposite, and there was the Henry critique that models were not tested properly. None of these is right, actually. The right issue is that the causal mechanisms need to be discovered. The real world, everybody, all three people, Lucas, and actually Lucas is closest to what I am saying. Lucas says that you have to go to the real world mechanism, but the problem is that Lucas assumes that the real world mechanism is known, and that is that there is an optimizing consumer. So he said, instead of looking at fitting equations, let's go to what is happening in reality. But what he assumes about what is happening in reality is false. So that's the problem. So basically what he says is, let's assume that the consumption knows his lifetime income. He knows exactly what he's going to be earning this year and next year and up to the end. And so now what is he going to do? He's going to maximize his consumption. So what happens when you look at a maximization model, if you do your calculus of variations, basically you have done static optimization, and some of you may have done dynamic optimization. So basically if you set up the utility maximization not for one period but for whole lifetime, and you have an income stream, so it turns out that the optimal pattern of consumption is basically, if you assume for simplicity that there is no discounting, then the optimal consumption is basically a constant stream of consumption. So income can be anything, up, down, volatile, but your consumption will be flat. Why? Because basically you have diminishing marginal utility of consumption. So suppose that in one period you have less consumption and in the other period you have high consumption. Then in the period in which you have high consumption, your marginal utility is low, and in the period in which you have low consumption, your marginal utility is high. So you would want to transfer some consumption from the high consumption period to the low consumption period, because you're getting less out of the excess consumption and more if you give consumption to yourself when the consumption is low. So basically, by making such changes, you can see that the consumption stream should be constant. Now, how can you achieve that? Well, basically, you smooth your income stream by savings. If you have more income than you can consume, you just save it so that you can spend it when you need it. And if you have less income, then you borrow. You borrow from your future income. So as long as you have perfect capital markets, there is no problem. I mean, you can borrow at market interest rates, which if they coincide with your discount rate doesn't cause any problems. Or if you have zero interest rate in the zero discount model, it comes out to constant income. If it's not constant income, then it's basically smoothly varying income in the more general model where you have discounting and where you have interest rates. So basically the income stream can be very erratic, but the consumption stream will be very smooth. We saw this actually in the data, that the consumption stream had a fairly smooth seasonal pattern. The income stream was more erratic. So in that case, if this is correct, if the rational expectation, then what happens is something very strange. The consumption does not depend on current income, because your incomes are all taken into account. You are not looking at what's happening in this year. Your consumption function is determined by your past income and your future income and your lifetime income, which is always fixed. So income will simply not matter. So what happens is that consumption only depends on CT minus 1. Why it depends on CT minus 1? There are some reasons for that. Many different explanations can be given. So this was the Hall actually created a model like this and tested it, and he showed that this is correct. He showed that the consumption did not depend on income if you put in CT minus 1. So he sort of verified that the rational expectations is true. But many people later attacked this and found that his finding is wrong, and they found that consumption does depend on current income and on other variables which rational expectation does not allow. So a lot of empirical investigation was done, and it was found that consumption is not sensitive to interest rates. This is again contrary to rational expectations, because interest rates is the variable which makes, and basically your current spending depends on your net present value of income, not on your current income, according to both in the life cycle hypothesis and also in the Lucas critique and in the rational expectations. We look at the present value of your income, and the interest rate makes a big difference, because that is what is used to transform future income to present income. But empirically, interest rate makes no difference, or very small. And it is sensitive to current income. Again, this is contrary to rational expectations, contrary to Lucas, contrary to Hall model. And the third finding is that a high average propensity to consume, when you observe it in the data, that the ratio of consumption to income is high, then after that usually you see rising income. So those are the empirical findings. That's what the data tells you. So basically, from this data analysis, we conclude two things about the kind of model that you need to make to explain this. So one of these things is that there are liquidity constraints. Even basically the third finding, high APC followed by rising income, means that people are spending money which they anticipate that they will be able to earn later on. That's what it means, that your proportion of consumption to income is high when the future income is high. So people can forecast income to some extent, and then basically they will do consumption smoothing. If they know their income is going to rise next year, and this makes very plausible sense if you think about yourself, that even if somebody is very poor this year, if he is quite comfortable and convinced that next year I have a job which will bring me a high income, then he will be freely borrowing and spending, because there's no need to be very stingy this year, because your income is guaranteed for next year. So you can borrow some to avoid. Basically this same argument, marginal utility of consumption is high when you are spending less, so you should borrow from your future income. So that's what the third. So now the thing is that the consumption, you cannot borrow fully. If you could borrow fully, then your current income would not matter, because what would matter? But if there are liquidity constraints, what that means is that you cannot borrow. I mean, you know that your income is going to be high next year, but nobody else does. So you can borrow some proportion, but you can't borrow all that you would like to borrow. So these are liquidity constraints, and also you have forward-looking consumers. That means that consumers do know what is going to happen in the future, and they are making plans on the basis of that. So that's very interesting, because many of the models that we are using, the permanent income hypothesis, are only backwards looking. They say that we look at what is happening to the consumption and income in the past, and we create an index of permanent income, and that's what matters for determining current income. But these are not forward-looking models. So actually, future income can also affect current consumption. This is a strange implication of this.
Excuse me?
Yes.
So you said consumption is non-sensitive to interest rate.
Yes.
But consumer is going to borrow, then the cost of borrowing is the interest rate. Then it becomes sensitive.
Yes. If that's the standard assumption, that actually people borrow to in light of future income. But actually what is more likely true, and what there is a lot of evidence for, is that basically people want to maintain a certain level of wealth. It's a good question that you've asked. So if people have internal assets, they have wealth which they can draw upon, then they borrow from this wealth to, they reduce their wealth because they anticipate that they will be able to build it up. So they actually don't have to go into the market to borrow. Same thing happens to firms. And the firms, if they have their own savings, then they use it to invest. But if they are liquidity constrained, they don't borrow in the open market. So in that case, there is no effect of interest. But that also means that there are liquidity constraints. And people who have the wealth so that they can comfortably borrow, they have a cushion, then they will destroy that cushion, because they say that, we can build it up back and again next year. But those people who don't have the cushion, they just sit tight, and therefore they don't borrow. If you look at the aggregate economy, people are not borrowing as much as they should to maximize utility, because those people who have their own wealth, they can borrow from it, but nobody can borrow on the open market. So that is liquidity constraints and forward-looking consumers.
But say if he borrow from himself, still there's opportunity cost.
Yeah, if that was true, if you could use that money and lend it out and get interest on it, that would be an opportunity cost. But again, if the capital markets are imperfect, as they say, you can't lend your money and make money on it, then the opportunity cost is not there also. Okay, so why does rational expectation and life cycle hypothesis fail? It's because of liquidity constraints. It's because also of unanticipated income. Basically, you cannot predict what your income stream is. So, if you think you are planning your consumption according to the idea that this is going to be my income stream, and then there is a surprise, your income jumps up or it jumps down, then you will say, oh, now my income is changed from what I was thinking. And every year there will be some surprise. So then people started modeling that what is the predictable part of income and what is the unpredictable part. So there was permanent income, and then there was transient income, the income which is different from your expectation. And then they said, okay, the MPC to consume out of these two kinds of income can be different. And so they built models around these, and basically if you build optimizing models with this liquidity constraint, then you get something which looks like an error correction model. So basically if you are an empiricist, you say, okay, all of these are covered. If I do an empirical, if I do an ECM, then whether it's rational expectation with liquidity constraints, or whether it's habit formation, or whether it's the life cycle hypothesis, it doesn't matter. All of these are covered in my equation. But this is the wrong idea and the wrong approach. Basically, you need to know which of these mechanisms is working in the real world. But the thing is that you cannot tell it from the data. Okay, so we examine the consumption function in UK, and you find that the average propensity to consume fell in the 70s and then it rose in the 1980s. Why did that happen? Then there was a very huge increase in consumption in the late 80s. Again, increase means that the models don't pick it up. I mean, the model predicts an increase in consumption, but the amount of increase that actually took place is larger. All of these are pointing out that there are some factors in the consumption function which have not been taken into account. So there is something which explains consumption which we don't know about. So DHSY badly underpredicts in 85. For that reason, the HUS was Henry Ungerberg Stern model was formulated, and that fixed that. But if you have then that model also failed, but there was some addition made to it, correction made to it by adding some interest rate variables, and that fixed the problem for a little while. Then again it failed. So then there was the LBS model which was formed. All of these are covered in your chapter 10, which fixed the HUS problem. So this is the third stage model. And what it did was that there was basically people looked at what was happening in the real world, and they found that what was happening is that the house pricing world was rising. Why was the house price rising? Well, basically what happened in the 80s in both USA and UK was that this was the Reagan-Thatcher era, where for the first time the financial deregulation was taking place. Basically, the banks had collapsed in 1929, leading to the Great Depression. So after that, and why had they collapsed? They had gambled wildly. They had put the money in stocks, and because the stock market was going up very fast, so they were putting a lot of money in there. And then when the stock market collapsed, there was no money left in the banks to pay, The banks collapsed, savings of all the people were wiped out, and there was huge economic catastrophe. So after that, there was a very strong banking regulations were made that banks can't do this. There was the Glass-Steagall Act, which said that banks cannot invest money in stocks. They have to make very safe investments. So for 50 years, things were all right. There were no bank failures. But then in 1980s, Reagan-Thatcher deregulated. The banks started gambling again, and quite fast. And one of the areas that they were gambling in was real estate. When the real estate, when more money became available for real estate, then what happened was that the housing prices started to rise. And what happened also was that people whose housing prices were rising, see, if you have a house worth $1,000, you can take a mortgage on it. Mortgage is a secured loan, so it's relatively easy to get. Basically, that's the point of our financial system, is that it gives, you can get a loan not on the basis of your future earning potential, but on the basis of collateral, something you have to offer that if you don't pay, I will seize it. So this housing, this additional market value of the house created collateral, so people were able to borrow against this. And so they could potentially remove the liquidity constraint, and they could borrow against future income, and they would then be able to spend that money. And so the LBS model has a variable called housing wealth drawdown, which means that basically additional wealth which is created in the housing market is taken out by people by taking out mortgages, and then second mortgage, third mortgage sometimes, and then using that money which you borrow from the bank to do whatever you like, consumption. So this model fixed the problem of under-prediction of HUS, but still doesn't quite fit the data very well. So that's housing equity withdrawal. So why is the APC high? Because people are consuming more. Why are they consuming more? Because the housing prices rise and they can borrow against it. So there's another paper by Mulbar and Murphy which argues that housing increases, and also stock prices were going up again because a lot of additional money was available, so people were investing in stocks and people were investing in housing. If you want to get more details, you can listen to my macro lectures which I have recently recorded, and you will find out more about this. So there was also financial liberalization which made it possible for people to borrow, lessen the liquidity constraints. And also there was fairly incomes and employment, etc. streams were very smooth, so that meant that people did not feel that they needed to save as much because they could predict what was going to happen. So these are basically all studies which are coming one after the other and improving on the previous one, following the encompassing methodology. So they, Curry, Hawley, and Scott created a model in which there was co-integration between consumption, income, and wealth, and then they introduced a financial liberalization dummy, and they also put in interest rates, and they got a model which was better than the previous one. And basically, for long run purposes, the important thing to note is that the wealth variable is important, and financial liberalization was significant. That means that basically the ability to borrow in the market makes a difference. And if borrowing is important, then of course interest rate is going to be important also. One more thing is that this means that the equation can change from time to time, and if there is financial liberalization, then interest rate will be important. If the financial market is very stringent and people can't borrow, then interest rate will not be important. So in different periods, different variables can be significant and different models may be valid. Okay, so in the end there is a conclusion about what we learned from all of these estimates of the consumption function. But the last thing is that basically what happens is that people come up with a new consumption function and it fits the existing data very well, and then the next year the prediction is completely off, and then they say, oh, we must modify the model, and this just seems to keep happening. So the problem is that without referring to the real world, no learning takes place. If you're just looking for a model which fits well, models can fit well because there is an infinity of models and a finite number of data. So there will always be models which perfectly fit any data but are wrong. So then the only thing you can do is to find out what is the real world causes. If you find out the real world causes, then you can have learned something. If you say that, okay, the wealth matters, so then any model which doesn't include wealth, no matter how well it fits, can be thrown out. Exactly, you can see this process in the DHSY because the Henry model, which had seasonal variation and time varying seasonals, is totally ridiculous from theoretical. So even though it's very good fit, so we should just ignore the good fit and realize that this model doesn't correspond to the real world, so it must be wrong without having to fit it. So basically this idea is not realized by the empirical methodology, and people are just looking at the model which fits well, and there is so many examples all the time that model can fit well and be wrong, and so just fitting well is not the criteria. People don't realize it, and they say, okay, this model has 0.99, the other one is 96%, so this model is better than that. That's nonsense. It doesn't have any meaning. If one model fits slightly better than the other, it's just statistical phenomena. What matters is which model is more accurately matched to the reality. This is something which simply has not been realized. People, even now, you see what people did. Let me just close with this. They said that, okay, let's look at forecasting methods. So there are a huge number of forecasting methods for time series. There's the ARMA models, there is the state space methods, which are there are exponential smoothing models. There are hundreds of methods for forecasting time series. Okay, so they said, okay, we'll have a forecasting competition. There were 1, 2, 3. There's the Journal of Forecasting, which ran these international forecasting competitions. It said that, okay, you send me an algorithm for forecasting, send me a program, I will feed it some 100 real series, and then we will see which method works the best. And if you wanted to enter the competition, they would give you some 10 or 15 or 20 series as a pilot or a starter kit that you can calibrate your method on to see how well it's working. And they would take the full series, which could be 150 or 600 real world time series, and they would say, okay, let's find out which method works well. And so in these competitions, many people sent their entries that this is my program, and they made up methods. And at the time when it was going on, I was also, I didn't have the understanding of the, because I was also, the standard economic methodology is empiricist. So I couldn't see, and they couldn't see, that this whole thing is meaningless. This exercise is meaningless. Why? Well, basically, it is not that there is one good technique of forecasting. There are no good techniques of forecasting. Forecasting works well if you understand the real world mechanism which is generating the series. There was something which was called the Harvard barometer that was used to predict macroeconomic time series. So what they did was they took a lot of series which have correlations with each other, and then they said, okay, this when, for example, housing construction goes up, then the GNP goes up. So this is one of the leading indicators. So whenever housing construction goes up, we will going to forecast that GNP will go up. So most of the time this works because there are correlations. But if the correlations are just an accidental match, then something happens and then the correlation is disturbed. Two things are going along together, but they don't really have any relation. So then one thing can move and the other thing need not. If there is a relation, if there is a tie, causality, then when this moves, the other has to move. So if you just look at correlations, anything can happen. There was this, in the US elections, there was this pattern that for about 50 years, whoever won the New Hampshire primary, and New Hampshire was a small state, would also win the US elections. So people started to focus on this, that it has to be, and if you can win the New Hampshire, you can win the US elections. But it was just an accidental correlation. 1 year it didn't happen, and then. So accidental correlations are not sufficient to build models on, and basically, as we have said, these are observational studies. All econometrics is observational. So observational study doesn't give you any reliable indication of the causal forces. And if you don't have, so which model is going to work well? Well, the forecasting method which most closely matches the real world mechanism which is generating the data, that is going to work well. But you don't know the real world model, and you don't know whether there is a match, so there is nothing you can say, and so the results will be random, and that's exactly what will happen. I mean, some methods work well on some series and not well on others. Basically, what's determining is not that I have a good method. There is no good method. The good method is the one which matches the reality which you don't know. So wherever there is a match, and the match will be by accident. So some methods work well on some series, not on others. Other methods work well on those series and not on others. And there is no way to decide which method is good and which method is bad. So they did this competition for 3 times, and then they decided that we don't learn anything from these forecasting competitions. So they stopped. But still they don't really have an understanding of why they didn't learn anything, because the methodology is an empirical methodology. It's not a realist methodology. This is basically in the philosophy of science, there's a difference between realism and nominalism. The nominalist philosophy says that the appearance is all that is there. There is nothing behind the appearances. So what you see is what you get, and basically the observations is all there is. And the realists say, no, there is something behind. Basically, if you have an electron doesn't exist because it can't be seen. It's only what can be seen. Gravity doesn't exist, but basically you can see the orbits. So the observable orbits are the reality, and the unseen gravity doesn't exist or doesn't matter. So basically that's the nominalist position. Nominalist position is wrong, and in fact it's very interesting that this whole philosophy was invented to deny God, because they said that, well, what is observable is all that exists, What is behind, nobody can know. So it's exactly, this is the same as the argument for God, that we cannot see God, but we can see the impact of God by looking at what is happening and then understanding that behind this is God. So they wanted to deny that what is behind it matters, but they found that even in science you cannot do that. If you cannot deny the existence of electrons, but still this way of thinking has become very influential, and that's what's causing the disturbance in econometrics. The current econometric methods are totally flawed because they don't take into account the real world. And interestingly, this happened because the Europeans denied God, and they said that, the argument which says that we can understand that God exists by looking at the air and the clouds and all of the harmony in the world that exists, that is so wonderful. There's this joke that this man there was going to be a debate between an atheist and a religious person, and so the religious person was late. So he said, "Why are you late?" He said, "I had to come from my home, and there's a river that lies in the path between here and my home. And when I came to the river, I found there was no boat, so I couldn't cross the river." So he said, "Then what happened?" He said, "Oh, what happened was very strange. A tree fell down, and then the branches broke off, and then they fitted themselves together, and the boat came up, and then I stepped in the boat, and I came." He said, "What nonsense, you must be a crazy man, how can this happen?" He says, "Well, you are saying this whole world with all of these things, they just happened accidentally, and you can't even believe a single small boat came out accidentally. What is this?" So basically this is the issue, that the reality is a sign for God. The nominalists and the empiricist philosophers rejected this argument, and they rejected all its arguments like that there is a sign which shows us the electron, but the electron itself doesn't exist. And similarly in econometrics, we have the equation which matches the observed data. What is behind the data doesn't matter. Whether it's life cycle or whether it's permanent, all of this is irrelevant. All that matters is that our equation fits the data well. So this attitude is wrong, but this is the current attitude which is causing serious problems in understanding why econometrics works and why it doesn't work, which equations fit. So we have these students who are running the rainfall in Argentina upon the crop in Japan and the exports of Pakistan because they think that this equation has something to do. And that's what you're taught, and that's what people do. Okay, so that's it. Thank you. I think I conclude here.
Excuse me, sir.
Ji.
So the main motive of the consumer is consumption is smoothing motive. But in